What is the biggest thing to come out of China? While many people will point at skyscrapers and other huge edifices, the biggest thing out of China might actually be empty, as the Asian country is bent on digging the deepest hole on Earth. Why is China digging this hole, and what are the risks to the rest of the world? Keep watching to find out. China has begun digging its deepest borehole in an effort to study areas of the planet deep beneath the surface. The drilling of the borehole began in a desert in the Tarim Basin in China's northwestern region of Xinjiang, according to the Chinese state-run Xinhua news agency. With a planned depth of 11,100 meters, the narrow shaft will penetrate more than 10 continental strata and reach the Cretaceous system in the Earth's crust, a series of stratified rocks dating back 145 million years. The project is expected to be completed in 457 days and has been hailed by Chinese state media outlets as a landmark in China's deep Earth exploration. The deep exploration well will allow scientists to study the internal structure and evolution of the Earth and provide data for geoscience research. China National Petroleum Corporation, the country's leading oil and gas producer who leads the project, said in a statement. Wang Chunsheng, a technical expert involved in the operation, described it as a bold attempt to explore the unknown territory of the Earth and expand the boundaries of human understanding. It is not going to be an easy feat, however. The construction difficulty of the drilling project can be compared to a big truck driving on two thin steel cables. Sun Jinsheng, a scientist at the Chinese Academy of Engineering, told Xinhua. The equipment, which weighs more than 2,000 tons, is designed to withstand underground temperatures of up to 200 degrees Celsius and an atmospheric pressure that is 1,300 times higher. In addition to the extreme conditions deep below the surface, the harsh ground environment of the Tarim Basin, home to China's hottest and driest desert, adds to the challenge. The project is part of the country's efforts to explore new frontiers in space and below the Earth's surface. In 2021, Chinese President Xi Jinping urged the country's leading scientists to break new barriers in different areas, including deep Earth exploration. Separately, Xi Jinping has also stressed the need to boost domestic energy supply, pushing Chinese energy giants to look for natural resources. China's Xinjiang region is known to be rich in mineral deposits and oil. Only last month, Sinopec, China's largest refining company, found sizable oil and gas flows in an exploration well in the Tarim Basin at a depth of more than 8,500 meters below the surface. China's deep hole drilling project in the Taklamakan Desert could help reduce the country's reliance on imported energy by providing new information about the geology of the Tarim Basin. This region is known to be rich in mineral deposits and oil, and the data collected from the project could help Chinese energy companies locate and extract these natural resources. And by boosting domestic energy production, China could reduce its reliance on imported energy. This could have important economic and strategic benefits for the country, as it would reduce its vulnerability to fluctuations in global energy markets and potential disruptions to energy supplies. And in addition to its potential benefits for domestic energy production, the project could also provide valuable data for geoscience research, which could help advance our understanding of the Earth's internal structure and evolution. The drilling project could also offer researchers insight into the unique geology of the Tarim Basin. The basin collects water drained from 3 mountain ranges and is thought to have been formed during the closure of the Paleo-Asian Ocean more than 200 million years ago. The data collected from China's deep hole drilling project in the Taklamakan Desert will be used to study the internal structure and evolution of the Earth. According to a statement from China National Petroleum Corporation, the country's leading oil and gas producer which led the project, the deep exploration well will provide data for geoscience research. This data could help scientists better understand the composition and behavior of the Earth's crust, which could have important implications for fields such as seismology, mineralogy, and geothermal energy. However, China is going to run into quite a number of challenges before it completes drilling its deep hole, because digging deep holes is not for the faint-hearted. To start with, as China delves deeper into the planet, the temperature and pressure start to rise astronomically. Around the 3 to 5 kilometers mark, temperatures can already reach a scorching 70 to 100 degrees Celsius. And if China persists and goes down as deep as 12 kilometers like the audacious Soviets with the Kola super deep borehole, it will be grappling with temperatures north of 180 degrees Celsius. These are conditions that make ordinary drilling equipment wilt like a daisy under a heat lamp. But wait, there's more, of course. It is not just the heat, but also the pressure that puts the squeeze on China's ambitions. The deeper you go, the higher the pressure, reaching an astounding 4 kilobars, which is astoundingly 4,000 times atmospheric pressure at the deepest point. Regular drilling equipment crumples under such conditions. To face these intense pressures, engineers must create drilling muds capable of maintaining high pressure to prevent well collapse and blowouts. Next, China cannot ignore the remarkable unpredictability of the Earth's crust. The further down we go, the less we know about the composition and behavior of the rocks we're trying to drill through. At such depths, we encounter rocks that have been under extreme pressures and temperatures for millions of years, leading to bizarre and unexpected geological phenomena. China may run into rocks so plastic they flow around the drill bit, cavities filled with pressurized gas or fluid, or unpredicted seismic activities. It's like journeying into a mysterious subterranean wilderness. And now imagine having to navigate this unpredictable wilderness with a drill string that's over 10 kilometers long. Such length adds significant weight and causes considerable logistical issues. The longer the drill string, the more friction and potential for buckling or breaking. Moreover, such lengths also increase the time it takes to retrieve and replace a worn-out drill bit. One trip up and down at the Kola borehole in Russia took several days. Talk about a time sink. And then there's the question of steering. At such extreme depths, even a slight deviation from vertical can lead to the drill veering kilometers off target. This demands high-precision steering tools that can resist intense heat, pressure, and the rigors of drilling. Achieving this level of precision in such punishing conditions will be nothing short of a marvel of engineering. And yet there remains the elephant in the room that we still have to address: the cost. Digging the deepest hole on Earth is a feat that comes with a staggering price tag. The Kola super deep boreholes drilling in Russia ran for over 20 years and cost millions of dollars. With such a hefty financial commitment, one must weigh the scientific benefits against the resource investment. However, the challenge of drilling the deepest hole on Earth is not just about scientific curiosity and bragging rights. It's a testament to our species' ambition and inventiveness. China is pushing the boundaries of engineering, creating new materials able to withstand extreme conditions, developing new drilling techniques, and expanding our understanding of our own planet. It's hard not to get excited about what we'll discover next in this grand subterranean adventure. But putting our excitement to one side, there is safety to worry about, from preventing blowouts due to unexpected pockets of gas to maintaining the structural integrity of the hull to prevent collapse. Each step must be meticulously planned and executed. An accident at such depths could be catastrophic, not only endangering lives but potentially causing untold environmental damage. And we haven't even talked about the Taklamakan Desert itself. The Taklamakan Desert is the largest desert in China and the second largest shifting sand desert in the world. It lies in the Tarim Basin of Xinjiang in northwest China and is bounded by mountain ranges and the Gobi Desert. It covers an area of about 330,000 square kilometers and stretches 960 kilometers from west to east and 420 kilometers from north to south. It is nicknamed the Sea of Death, or the Place of Ruins, because of its harsh and dry climate and its isolation. It has extremely cold winters and warm summers, and sometimes experiences snowfall. The weather conditions of the desert are such that not much green cover is possible. The Taklamakan Desert is best defined as a wasteland due to its harsh temperature and lack of rainfall. Because of this, there is no cover of vegetation in the desert. And in addition to its extreme temperatures, the Taklamakan Desert is also known for its shifting sand dunes, which can reach heights of up to 300 feet or 91 meters. These dunes are constantly on the move, driven by strong winds that blow across the desert. And so, with these numerous and significant challenges, it's clear that drilling the deepest hole on Earth is not for the faint of heart. However, there are serious risks that China is taking here. Down there in the inky depths, ancient microorganisms lie dormant, locked in time, offering a captivating puzzle for science but also potentially opening Pandora's box. First and foremost, we must understand that the deeper we dig, the further back in time we go. Every meter of depth equals thousands, if not millions, of years in geological terms. So if we're drilling 10 or even 12 kilometers down, we're essentially venturing back through billions of years of our planet's history. In this primeval environment, China might encounter ancient microorganisms that have been isolated for eons. Sealed in their subterranean chambers, they've been biding their time away from sunlight, oxygen, and modern life as we know it. It's an alien world beneath our feet, potentially teeming with life forms that our immune systems have never encountered. Imagine this scenario: China drills down, extracts a core sample, and unwittingly brings up a strain of ancient bacteria or a virus. Once exposed to our modern atmosphere, these organisms could revive. Sound far-fetched? Well, this isn't pure speculation. In 2007, researchers successfully revived bacteria that had been encased in Alaskan permafrost for 32,000 years. Now consider the potential health implications. What if one of these ancient viruses or bacteria prove harmful to humans? Our immune systems, having evolved without exposure to these pathogens, might be defenseless. The health impacts could range from new allergic reactions to potential pandemics. Robust biosecurity protocols will be essential for any deep drilling project. Samples would need to be treated with the same caution as those collected from biohazardous environments or outer space, requiring stringent containment and testing protocols. Interestingly, though, there's also a chance that ancient organisms might not be harmful but beneficial to us. They could hold the key to new types of antibiotics or other medicines, providing us with new tools to combat existing diseases. But even this bright prospect doesn't negate the need for extreme caution. And the challenge of ensuring safety in deep drilling projects is immense. Prevention of accidental contamination requires not only cutting-edge containment technology but also extensive training for the drilling personnel. Furthermore, the development and enforcement of international regulations would be needed to ensure global safety. And then there's the environmental impact. Any potentially harmful organism brought to the surface could wreak havoc on local ecosystems, disrupting the ecological balance and potentially triggering a cascade of environmental issues. However, it's essential to note that this whole scenario might be hypothetical. Most microbes deep within the Earth's crust are likely to be simple organisms adapted to conditions of extreme heat and pressure, and unlikely to survive, let alone thrive, in the surface world. Nevertheless, it is a hypothesis that China needs to thoroughly investigate scientifically.